Uncertainty is one of the biggest challenges that we face when we work on financial models. In this video, we're talking about Monte Carlo simulations and how we can use this method to dramatically improve our financial models. We'll break down what it is and how it works, and then I'll show you how you can quickly add it to pretty much any model in Excel. Let's dive in. The way we traditionally work with models is you have your model with a set of assumptions in it, and then to provide the result. You can then have a separate version of the assumptions or an entirely separate version of the model, and it's going to give you a different result. And that's how we will traditionally approach financial modeling. When it comes to Monte Carlo simulation, what we're essentially trying to do is we're introducing randomness within the model. So all those assumptions and calculations that have inherent uncertainty, we're introducing this within the model with randomness, and then we're running multiple iterations resulting in different results, but for the same model. We're grabbing all those results and calculating an average. That way we can account for the uncertainty in our model by introducing randomness in it and essentially running enough iterations, like in the hundreds, thousands, tens of thousands, to make sure that we're always getting like the actual most likely result. Here I have a dummy table that I generated with ChatGPT, so don't pay attention to the details in it, that has employee data and their salaries, and we are faced with the following scenario. So in this company, there's a downturn in the industry where they operate, which results in the company getting less orders. Management expects this to last a few months, and they don't want to let people go and have to rehire them pretty soon. So they've come up with the idea to decrease the work hours and salary for employees for the duration of this industry downturn. And it's our task to estimate the potential savings from this program that they're planning to introduce, and we'll use a Monte Carlo simulation to do that. Let's start putting our simulation together. Here we'll have header, and then we'll essentially have a few variables. We'll have a participation variable, essentially saying whether people will participate in this program or not, and we'll have specific chance percentage, saying what percentage of the people are we expecting to say yes, and what percentage are we expecting to say no. Let's go for now with 65%, and the rest will say no. So we're expecting that 65% will say yes and will participate in this program to help the company weather the storm. Then in terms of the decrease that they'll agree to, let's say 20% to 30% is what we expect. And we can calculate this with a rand between, and we'll use that for our Monte Carlo simulation later. So the way this formula works is we'll have rand between, and we'll say 20 and 30, and divide that over 100, and that way we're getting a percentage. Now let's move over to the side and add some calculations. So first we'll calculate the total cost for each employee. I'm gonna see if they will participate and what the decrease would be. Okay, let me expand those a bit. So the total cost for each employee, I'm gonna say if is number, say this here. I wanted to only calculate where I have actual numbers. Then I want my gross salary plus my employer social security contribution. So those are deductions from the salary, taking the salary plus the employer portion of the social securities. Otherwise, I want just an empty cell. I can then go ahead and select all this, Control D to copy it all down. And now I have this total cost formatted a bit. Maybe you can zoom in a bit easier to see. For the participation, we're going to say if S number, this here. Then we'll say if, and here I'm going to use a rand, essentially give me a random value between 0 and 1, and I can compare that to the percentage, because percentages are from 0 and 1 essentially. So if a random value is below 65%, I'm going to fix that with F4. Then I'm going to say yes. And if it's above 65%, so it's in the other 35%, I'm going to say no. And otherwise, if it's not a number, it's gonna leave it empty. Okay, let's copy that down with Control D. And now we have yes and no, depending on what the random function returns for each employee. And you probably noticed already that every time I do something, all those change. And you can simulate that by pressing F9, which recalculates the entire sheet. And random formulas like rand in here and rand between, they recalculate every time sheet is being recalculated. So they give us a different value every time we change anything in here. For the decrease, I'm gonna check if the participate is equal to yes, and if it is, we'll grab this percentage here, fix it with F4, and multiply it by the total cost. Okay, and otherwise, we'll just give a 0. Copy that down, format it as a number, and we get our decreases here. We can now start calculating a few supporting items here. So the total cost will be my sum of this whole thing. Then we can see our decrease, and it's going to be the sum of this column here. And we can calculate a decrease percentage to see essentially what our savings would actually gonna call it a savings percentage. This is gonna be my decrease over my total value, and I'm gonna show it as a percentage. Let's format that a bit. So you see that currently we're using randoms, but imagine that in the traditional sense, we'll fix this. So which ones would be yes or no? We'd fix this decrease based on some assumptions, and we'll calculate our percentage. But you see that as I'm pressing F9 and recalculating, this varies wildly. You have 16, 18, 21, 15, there was an 11 earlier. So based on where we land with our assumptions, this can be quite different. And you see that what's happening here is that we're trying to model for uncertainty, and this leads to huge swings and potentially can lead to a misleading result. That's why we'll employ the Monte Carlo simulation method here. I'm gonna add 2 more columns here, are gonna be iteration and decrease, and we'll use those to store our Monte Carlo simulation data. Here we'll have a number of iterations to run, and this is essentially where we'll set how many iterations we want the Monte Carlo simulation to run for. Start with 10, for example. Here, I'll calculate an average decrease, which will essentially be the average of this entire column. And I'm gonna copy this thing here and say that this will be my average decrease divided over my total cost. Right now, it says division by 0 because we have nothing in here, but once we populate our iterations here, we'll calculate the average savings percentage based off of our Monte Carlo simulation. I'm also going to add a button here. I'm going to go to the developer tab, and if you don't have the developer tab, right click, customize the ribbon, and just make sure that it has the check mark here. And I'm going to insert a button, add a big button here, and we can assign a macro to it. So I'm going to say a new macro, and it just called it button to click. I don't care about that. You can have like a specific name that you want to use and then add the button and assign it. But this macro that we're going to write here will be what runs the Monte Carlo simulation for us. And before you get like frustrated, I know Excel VBA might be a bit intimidating, and a lot of frustration can stem from it because it just hasn't been updated for so long that it's pain to work with. But the macro we're writing is going to be really simple. So let's just go ahead and jump right into this macro. So I'm going to split the screen like that so I can see what we're doing here in Excel, and I can write my macro at the same time. So first we're going to define a few variables. I'm going to say dim to define a variable, decrease as double. It's going to be a number where we store each decrease. Then we'll have a row number where we're going to store which row is currently being calculated. It's going to be a long number. We want to make sure that even if we are running like hundreds of thousands of iterations, it can handle it. And then I'll need the last row just to know where I'm placing each iteration. It's going to be along again. And the last thing we're going to have is WS, which is going to be a worksheet. And this will be the worksheet we're working with. I'm going to start by setting the worksheet to this workbook.active sheet, and this will essentially set this variable to the active sheet, and this is our active sheet. Then I'm going to say last row equals my worksheet cells, and I'm going to say worksheet rows.count, which is going to count all the rows. This will be my row index for cells, and then I'm going to grab 28. This is my column. So essentially, if I come from here and I select like that, you can see a small counter up on the left, and you can see that number 28 is AB, my iteration. So what I want to do first here is grab the last row where I have a stored iteration and clear all the previous iterations to avoid a situation where I've run, let's say, 30 or so, and then I run 10, and it only replaces the first 10 but leaves the rest. Then I'm going to use end Excel up. So this essentially finds the end from the bottom up, and I'm going to grab the row number in it. Then I'll say range, and in quotation marks, I'm going to say AB2. So from here, from AB2, the second row to AC, and I'm going to concatenate my last row. So that way I'm defining a range that, for example, if I have this many iterations, it will start from here and select this thing essentially. And I'm just going to clear those. Now that I have those cleared, then what I'll do is I'll set last row to the number of iterations that I want to run. That way, as soon as I hit this number, this will be my last row, and I'll stop running additional iterations. So here we'll say cells, and as you see, we can be like WS cells, or we can just use cells if we're sure that the user hasn't changed the sheet and we're the user, so this also works. I'm going to say 15, which is my row index here, and V is my 22nd column dot value. This will grab the number of iterations that we want to run, and then we'll use a simple for loop. So we'll say for row number equals to 1 to last row. So we're iterating from 1 to the last row. I'm going to close this by saying next row num. So essentially everything that happens between those two lines will happen for 1, for 2, for 3, for 4, up to the last row. I'm going to indent that. And here I'm going to say that I want to calculate the sheet. So essentially I'm recalculating it. Remember, when we're recalculating the sheet, which we can do with F9, changes all the random numbers. And this is what we want. Then I'm going to say cells row number plus 1, because remember, we're skipping this first one. And column 28, which was our AB column, equals row num. So I'm storing the iteration number here. Next, I'm going to say cells row num plus 1, column 29, which like AC might decrease. And what I want to do here is for each recalculated iteration, I want to store the decrease in here. So what I'll do is I'm going to say that this equals cells 12 for this row here, and V was column 22, so this is column 21, 12, 21 dot value. So what this would do is for each row number, it would take what this amount is after it recalculates and store it in this column here. And I'm also going to add a counter. So here I'm going to iterate from 1 to this number here, so I have like a visual representation of where I'm at during the process. I say cells, and this is just going to be 16, the row number, 22 for column V, dot to value equals row num. And I notice here that I forgot to add dot value here and dot value here, so that it knows that it's setting the value of this cell to this on the right hand side of the equal sign. And that's essentially the whole thing. So this will run and make sure that we are applying randomness to our model. Let's test it out. First, let's right-click this, edit text, and I'm gonna say, yeah, that's a bit buggy, but I'm gonna say run Monte Carlo Sim. Hope this worked. Yep. So I have 10 iterations here, and if I run it, you see that it immediately did those 10 iterations. And there's a small bug here, which is that because we initially tried to find the last row number in this column and there were no iterations, it actually started from the first one here and it cleared out our headers. So I'll just add them again, iteration, decrease, and now we won't have any issues because we now have some data in here. Okay, so 10 iterations were like instantaneous, and you see that we got about 15.4%. I'm actually gonna note those down. So run one, gonna say 10 iterations, and we got 15.4% of savings that we can expect. Let's see what happens if we run 100 iterations. You run again, and you see that it's calculated those down here. I'm gonna say run 2 was 100 iterations, and it says that I can expect to save 16.4% of the total salary cost based on the randomness that we are introducing in our model to cover for the uncertainty of whether people would agree and to what amount, what percentage of a cut they'll agree. Okay, let's now do 1,000 iterations. Run that. You see the counter here, and okay, now we're getting somewhere. And the way we know that we're getting somewhere is that we increased our iterations to 1,000. Now run 3, and we're still pretty close in terms of percentage, but keep in mind those are a large amount, so even 0.1% can be quite significant. Let's go ahead and do that with 10,000 iterations and see what that yields. Okay, this is now starting to converge and be pretty consistent around 16.2, 16.3. So maybe that's the best representation of our model is somewhere around 16.2 or 16.3. Run 4, 10,000, 16.3%. And I'm actually going to have those calculated, the side, this multiplied by this, F4, and let's copy that down. And let's separate this, move it to the side a bit, so it's a bit better, a bit easier to visualize. Okay. So I'm seeing that now we are like getting pretty close. So this is not a huge difference by no means. So let's go ahead and run it for 100,000. And this is a complete overkill for a simple model as this. So I would rarely go above 1,000 or 10,000. And even if it's a more complex model, keep in mind that this right now is quite simple because we only have like 80 rows of random things that are being generated in just 2 columns. But if you have like something a bit more complex, so for example, I did a Monte Carlo simulation for a sales estimation, and it was like thousands and thousands of rows, and it took quite a while to run the whole thing. Okay, let's see how long would that take. Okay, this took about 6 minutes to run, and granted, I'm doing this on my desktop computer, which is pretty fast. And this was just a simple example, but I hope it shows you how powerful Monte Carlo simulations can be. They can be very quick to set up if you just keep this macro in a cheat sheet somewhere. Granted, working with multiple assumptions and large sets of iterations can become somewhat slow on an older computer especially. But I honestly believe that spending even 30 minutes to run 10,000 iterations on a more complex model is extremely useful as it helps us ground our estimates from a statistical point of view. I actually have an entire ebook on Monte Carlo simulations, which follows a bit of a more complex approach than this one, and you can download it completely for free from my Gumroad store, which is linked in the description box below. Now that you know how to run Monte Carlo simulations on your models, you probably want to dive deeper into financial modeling, and I've recorded a full beginner-friendly financial modeling course that's available absolutely for free right here on YouTube. You can check it out in this playlist up here. It will take you from an empty Excel spreadsheet all the way through to a fully dynamic, assumptions-driven financial model that you can use for any business. Thanks for watching, and I'll catch you in the first video.